And today on the bench we have a Kenwood TS-140S. This is a all mode, so AM, FM, upper lower sideband, and also does CW, wide and narrow. I was kind of unclear as to what exactly was supposed to be wrong with this thing. The note that I got with this, sending you a radio in hopes of repair. Let's see, Kenwood TS-140S HF Transceiver and microphone. So yes, this is the customer's microphone. The unit turns on, powers up, but will not work. I'm unsure what problem is. It just goes on with some other stuff, but I hooked it up using the customer's power cord, which man, I got to do something with this. This is not. He just needs a new power cord. Honestly, is what he needs. It's spliced together here. There are frayed wires hanging out the back of the connector here. Yeah, there's some old chassis mount fuse holders here. Actually, it didn't even look like. That's kind of red stripe. Yeah, actually, these wires aren't exactly the same as these. So, yeah, I don't know what's going on there. But I originally hooked it up with my power cord. Radio seemed to be working just fine. As a matter of fact, last night I had it on. Lord knows, I had it to the point where it was, right about now. It was warm, but I never operated it long enough for it to get to the point where the fan came on. So today, fired it up. Everything was working fine. Now, last night I think I only had it on mainly. I think it was the 10-meter band. I was up around 29 megahertz somewhere when I was trying it, just trying to see if it transmitted and received. Had it hooked up to a communications test set. It was receiving fine with acceptable receiver sensitivity. Today I played around a lot more with the band, so I started out, down at the bottom end and worked my way up through. And again, it seemed to be working just fine. Absolutely no problems. Output power was a minimum 100 watts on every band, and a little bit more when in sideband mode. But it'll do an AM or FM carrier of over 100 watts in all modes. So yeah, I didn't know what the heck was going on. And then all of a sudden it failed on me. Now let's see if it still failed. So if you look, I guess you can see the watt meter right there. So I have that in a 200 watt scale, so that's the middle. You probably, depending on your screen size, can't read the numbers, but it goes from 0 to 200 watts right hand side. So 1.5 megahertz. Huh. Is it just not working now? Did it just all of a sudden die? Huh, there it's working. Well, that's new. Okay, I lost another band. Audio. Yeah, would appear that it's not even switching to on air. And it's not loading the power supply down. There, kicking in there. It's just another radio I got turned on. It's unsquelching. Well, in any case, okay, 100. What do I got it in? AM. Go to FM. There's 120 watts. 120. About 100. Yeah, a little over 120 watts. A little under 120. About 115. 100. 100. And here's where it gets good. Light is switching, but you'll see the display kind of blinks, and occasionally it'll just completely go out. Nothing, and it's switching. You can hear the relay. It is switching into transmit mode. I guess I had that too far down, didn't I? Yeah, that's why. It was just transmit restricted. And I was below 1.8. And if I do this long enough, eventually the fan, let me just turn the power down a little bit here, and I hate these slide controls. Adjusting FM power is not bad, but man, trying to adjust the AM carrier power with these slide controls is a nightmare. But yeah, so that appears to be what the problem is the it loses transmit power on the higher bands, specifically, well, actually it loses more than just 10 meters, isn't it? Yeah, I guess it is losing more than just 10. Because it was, I think, 24 megahertz, I think, was out also, wasn't it? There's 21. Yeah, 24 is out. Now, I can hear my power supply. I'm running this off currently off of a 50 amp Astron power supply. Things are built like a tank. That's why I like them. They're just, I'm not going to say indestructible, but yeah, they're pretty much so. Those things just take a licking and keep on ticking for decades. But like most linear power supplies, when you heavily load them down, you can hear the transformer in the power supply start to sing, for a lack of better words. You can hear it humming. The more you load down a power supply, the more it starts to hum. And what I noticed was, when I switch from a working band like this and go up to a non-working band, I could hear my power supply loading down more, and there's nothing coming out of the radio. There's no power out. So, and there's nothing displaying on the watt meter, but it's apparently drawing more power, and I need to hook up an amp meter just to verify that. But I did blow a fuse. So I tried the customers. I had actually even switched back and forth just to see, maybe, because initially I thought maybe the problem was the customer's power cord, because it is kind of crappy, you know, wires hanging out, not knowing how good. And honestly, these fuse holders were getting really, really hot. So I'd switched back over to my power cord, and then a fuse blowing. I'm using, that has good Bussmann Band 20 fuses in it. They're fast acting fuses. Got a few hundred of these things. But all of a sudden the radio just cut off, completely dead. Checked my fuse, yep, I had blown one of the fuses. So yeah, for some reason it's loading down like there's a short, but it was working a while ago. That's the kicker. It worked yesterday, and it worked most of this morning, and then all of a sudden, once it apparently got hot enough, something happened. So yeah, we kind of got an interesting one here. I can't say I've ever experienced this fault, excuse me, with one of the Kenwoods. So let me get the covers popped off of this thing. It would have to be something in the band switching circuit. Is what I'm thinking, quite honestly, but I don't know what the relay, possibly bad, but it would have to be more than one relay. No, actually no. That's all the same bit, because you can hear the relays in these click. Okay. You hear that click inside. You'll hear the beep, but you also hear the click. That's the relay switching in and out for the different bands. But once I get here, no more click. So I don't know. I got to see what the band play, how the band pass filters are set up in this thing. Yeah, I'm thinking there might be something in the band switching for this. So anyhow, let me get her taken apart, and we'll see what we can find. Okay, so I've got her torn apart, and yes, the bands that we're having seem to be affected do go through just one of the band pass filters, which is kind of what I figured. And that would be what, this path right here. So this is all of your higher frequencies right here. Now, splitting these open, actually, man, these radios are a joy to work on compared to some other radios where getting the boards just, getting the two halves of the case separated a lot of times. Well, of course, there's going to be interconnections of wiring, but these are really nice because once you take the top and bottom covers off, there's really only 4 screws to get it split apart, and then it has these plastic hinges. So there's a screw here, and then 2 that come in from the back of the radio, screw into the back of the cabinet, and it just folds open. There's nothing to unplug. That's just it. 4 screws and fold it over. There is an RF shield that goes over top of this, so once you pull or flip that over, you'll have this plate. But take the screws, all of the screws out of this, plate comes off, and then you have full access to the PA unit, your fan, or actually the fan. Oh yeah, even it's under the squirrel cage cover there. And you'll have access to your band board. So it looks like it's probably just a bad solder joint. So I have taken the band board out, or the filter board out. Fairly simple, 1 TMP connector here, which is the RF output from the amplifier board, plugs in right there. Small connector here, 2 connectors on the side, and then you have a ground that goes to screw on the chassis, and you have the output to the antenna jack. And that's pretty much it. That's getting this out fairly easy. And again, there's a bunch of screws that hold this down. But if we flip over, remember these 2 relays right here are the switch this filter network in and out. And I don't know if I gotta find it again. Actually, let me pull this thing back. Right, let's see, there and there. Now, let me set this down so it's not moving around on me. So, let me get a pointer. And now I need to try and find it here. Where are we at in the pic? Oh shoot, let me put my finger on it. Right there. Yeah, it's kind of hard to see in the picture, but you can see the halo around there. If I turn the board a little bit. I just can't see it, but it is broken. There you go, starting to be able to see it. But you can see my pointer in the picture here. These are actually broken out. Man, it's just so hard to see in the camera view. In person with the naked eye, it's actually fairly obvious if you look really close. It's hard to get the camera angle. There you go. There you can see the nice black line going around there. So, and actually, at this angle, you can see the black line going around that terminal right there as well. Now, I think the reason that the fuse blows, and remember I said that I could hear my power supply just when I'd press the PTT button on any of those upper bands. I could hear the load on my power supply was great, and we had, remember, no output, but it was applying more load to my power supply than it was when the radio was in a band that it was actually transmitting on and putting RF power out. The reason for that is, if these relays fail, either the relay itself or if you have a problem, in this case, as I suspect with the solder connections there, these relays are grounded. When there's no power applied to these, each of these networks, matter of fact, you can see there's the diagram for it. The one side is actually, on each of these, the normally closed contacts go to DC ground. When the radio switches in one of these filter networks, it flips both of those relays into circuit. So it's basically the input and the output, it puts them in circuit. When that circuit powers down, and then to apply another one, both of those contacts are grounded. Well, if we're losing switching, if one of these relays is not turning on because of a bad solder connection, one of those contacts is staying applied to ground. So that means that we're grounding the output of the amplifier, basically a dead short from the center conductor to the shield, more or less, which would explain the heavy draw on the power supply and blowing fuses, and no output power, and why the display was dimming on when you go into those bands. So yeah, now what I'm going to do is that I will actually completely desolder those. It's always best when you have a problem like that. Don't just go in there and touch it up with a soldering iron. It's going to fail again. even adding a little bit of fresh flux and reflowing the solder on there, honestly, there's a lot of oxidation and stuff because that joint's been cracked out. It's best just take your desoldering tool, suck the old solder off, and apply fresh solder. Matter of fact, there's not exactly, especially when you have the proper tools to do it. Probably, honestly, what I'm going to do is I'm just going to desolder every single relay and I'm going to resolder it. I would hate to put this thing back together and then 6 months or a year down the road a solder connection fails on another relay, and then half a year to a year later a solder connection fails on another relay. You've got the proper tools, it's really fast. Just suck the solder out, resolder them, be done with it, and resolder them with a good lead tin silver solder so the connections are just physically stronger than what was on here, and should never have a problem again. So let me get that done. I'll get this put back together and we'll see if it works or not. Okay, I'm partway through desoldering all of these relays, and what I'm going to do is I'm in the process of doing is I desolder all of the terminals on one side of it on each relay. I'll resolder all of those, and then I'll desolder the terminals on the other side of the relay on all the relays, and then resolder them. That way, because if I desolder every connection on every relay, they're all going to fall out. Now, one thing I just noted, and remember what I just said, why am I doing this? To prevent having to do this again in the future. Well, someone else has already worked on this. If we actually look over here, you can see these, I desoldered one, but you can see those 5 terminals have been resoldered. So somebody's already been in here one time. And if they had done what I'm doing right now, I wouldn't be doing this right now. If someone had just desoldered all of them, resoldered them, it probably would have never, this fault would not have occurred again. So yeah, that's why we do stuff like this. Just because a lot of those solder connections may look fine doesn't mean that they haven't been stressed over the years. Because remember, these are mechanical. Every time you switch through with the band or you're spinning the VFO knob, these relays are clicking. That's mechanical. There's a little bit of vibration there. And just over the decades, that just eats away at the structural integrity of those solder connections. So, yeah, do it once and never have to do it again is kind of my point. Okay, so I've got the cover flipped back down now. And like I say, this is just how easy it is to open one of these up. 4 screws, I mean, other than take the top bottom covers off, but 4 screws and it just folds over. Just so nice. One last thing I do need to do is replace the meter light bulb. That is out, and it looks like that's been replaced before. So I've got this thing cooking right now to the point of, whoo, yeah, man, that is hot. And I can no longer hear the fan because the fan was horribly noisy before. It's one thing I did notice. Once this thing got hot enough for the fan to kick on, wow, it just rattled, and it hasn't been cleaned in a long time. The heat sinks fin here were just filled in with dirt and dust, so I've cleaned the heat sink off while I had the cover off for the PA and filter board units. I went ahead and cleaned the fan, the squirrel cage fan, took a dust brush and vacuum cleaner and cleaned that out and lubricated the bushings on either end of it. So, like I say, the only fan I can actually hear right now is the one on my oscilloscope running back there in the background. And easiest way, honestly, to heat test a radio, instead of you having to sit there and just talk for 5 or 10 minutes, is just turn on some music. Music has a really high duty cycle. Unlike what I'm doing right now, talking, and it's the reason actually when you're doing like sensitivity adjustments on a radio, they tell you to apply 30% modulation, because that is the average, basically, output power from your mouth. If you average what's coming out of your mouth, sound-wise, over time, it's only peaks at about 30% of the time. So if you really want to drive a unit hard, now I don't recommend doing extended transmit times with a continuous tone, because that is really hard. That'll be 100% modulation, 100% duty cycle. That's really hard on an amplifier circuit. But music is great, because music does have a higher duty cycle, because there's not only vocals, there's guitars and drums, or whatever your flavor of music is, flutes or ukuleles, doesn't matter. But there's more than one thing making sound, so it has a higher percentage duty cycle. So that's what I do. I just hit play, put on my favorite British death metal band, Napalm Death, and lock it down. And do that for about 15 to 20 minutes straight. And I've been switching through the bands, and as you can see, we're on 28.3 megahertz range, and it's working just fine. So, yep, that's all it was. Just bad solder connections on the filter unit board for all the relays, or for that relay. And it's sad because someone had resoldered one of those relays at some point in the past and didn't do the rest of them, and the radio's here to get fixed. You know, that's just that kind of stuff. Just little nitpicky things like that drive me nuts. If you've gone through the trouble of fixing the radio, just do a little bit of preventative maintenance and desolder all of them and resolder them. Yeah, because if one went bad, solder connections went bad on one, odds are they're going to go bad on the other ones at some point in the future. So better to do it now than later. So I'll probably just cut the video off here. I've tested all modes, upper, lower sideband, CW, AM, FM. Output power is fine. Actually, we can take a look at that again. Let me power up the whole way. Put it in FM. And let's see, we'll start off. So there's 1.8. And we got like 115 watts. Went too far. There's 3.86 megahertz. 120 watts. 7.36. 120 watts. 10.36. About 115. 14.36, 110, 18.36, 100, 21.36, 100, 24.86, 100, 28.36, just a hair under 100, 28.86, a little bit under 100, 29.36, down to about 90 watts, which isn't surprising, and 29.86. Right around 90 watts. As you get, and that's not uncommon, once you get up to the high end of the frequency range, output power does tend to taper off a little bit usually. But again, that's AM carrier. You'd never, or FM, and you'd never want to run this thing on AM or FM at that power level continuously anyhow. So there you go. There's a Kenwood TS-140S. Was a fairly simple repair. Had initially I couldn't find a fault, and once I got the unit warmed up enough, finally the solder joints started to go bad on it. So if you have one of these and the receive, and that's another thing you'll notice, the receive. If you lose a band or bands, because like I say, it depends which band you're in or bands. That filter board covers different frequency ranges, each one of those filter networks. So if the radio works fine on, you know, let's say 4 bands, and then the rest of the bands are bad, or you've got one band that seems to disappear, you don't have any receive or any transmit, or you may have receive, but the receive will be really low and you have no transmit power, or you could have low transmit power actually on any single band. Or if one of those relays starts to go bad, it doesn't need to be a bad solder connection where the relay's not actually switching in. If the contacts are starting to get arc flashed and it's making bad contact, you'll have full output power on all of your bands except for that one, because when the output power tries to go through that relay contact, you got to realize that's a couple hundred volts peak to peak AC voltage. That's what's, you know, at your antenna jack back there. When you're at 100 watts, you're talking a couple hundred volts peak to peak AC voltage there. So you may notice that if the contacts are bad. So that's fairly simple. And like I say, you just can't ask for easier access and servicing than one of these things. Kenwood really hit it out of the park as far as ease of serviceability for technicians. So there you go, Kenwood TS-140S ready to be put back together after I changed the light bulb.